Right now, billions of devices are quietly doing something extraordinary. Your phone, your laptop, the charger plugged into your wall, every single. One of them is solving a problem that stumped engineers for decades. They are taking electricity that flows back and forth, wild, alternating, untamable, and turning it into something smooth, steady, controlled. They are converting AC into DC, and the device doing this silent, invisible job? It's called a rectifier, and today, we're going to tear it apart. A rectifier is an electrical circuit that converts alternating current into direct current. Think of AC electricity like a river that reverses direction twice every second, 50 or 60 times per second, depending on where you live. Now, imagine trying to fill a bucket from that river. Half the time, the water flows in. The other half, it flows out. Your bucket never fills. And worse, everything in it gets pushed back out. That's what would happen to your electronics on raw AC power. A rectifier is the one-way gate that fixes this. It says, current can flow this direction only. The result, electricity that only ever moves one way. Not perfect DC yet, but a massive, critical step forward. The secret weapon behind every rectifier, a tiny, deceptively simple component. If you've never seen a diode before, here's what it looks like. It's small, often cylindrical, striped with a silver or black band on one end, but inside, it contains something almost magical, a PN junction. When you apply voltage in the forward direction, positive to the P side, the junction opens. Current flows freely. The diode is on. When you flip it, apply voltage in reverse, the junction slams shut. Virtually no current flows. On, off. Forward, blocked. It sounds simple, but this single property, unidirectional conduction, is the entire foundation of rectification. Every rectifier circuit ever built is just a clever arrangement of these one-way gates. Now, let's look at how those arrangements work. The simplest rectifier is called the Half Wave Rectifier, and it is almost embarrassingly simple. One diode, one AC source, one load. Here's what happens. During the positive half cycle of the AC signal, when voltage pushes current in the forward direction, the diode opens. Current flows through. Power reaches the load. During the negative half cycle, when voltage reverses, the diode blocks it. Dead. Nothing passes. What comes out the other side? Only the positive peaks of the wave. The negative half is gone. Discarded. You've gone from a wave that swings above and below zero to a signal that only pulses above zero. It's crude. It's inefficient. You're throwing away half your power. But it works, and in low-power applications, that simplicity wins. The half-wave rectifier is the proof of concept, the first step. But engineers looked at it and asked, what if we didn't waste that other half? This is where the real ingenuity begins. The full-wave rectifier doesn't throw away the negative half of the AC wave. It flips it. There are two main ways to build one. Method 1. The center tap design. You take a transformer with a center-tapped secondary winding, a special coil with a connection point exactly in the middle. This creates two equal AC voltages, mirror images of each other. Two diodes are connected so that each one conducts during its positive half cycle. When the top half of the transformer pushes current through diode 1, that diode conducts. When the bottom half reverses, diode 2 takes over. The load always sees current flowing in the same direction, both halves of the wave. Fully used, Method 2, the Bridge Rectifier. Now this design, this is engineering elegance. 4 diodes, arranged in a diamond. No special transformer needed. During the positive half cycle, current flows through diodes 1 and 3. During the negative half cycle, the path switches. Current flows through diodes 2 and 4. But here's the genius. No matter which direction AC pushes the current in, it always exits through the load in the same direction. Both halves. Rectified. No wasted energy. The Bridge Rectifier is the most widely used rectifier circuit in the world. It's inside your phone charger right now. Now, here's where most explanations stop. But we're going deeper. Even after full-wave rectification, the output isn't truly smooth DC. It's pulsating DC. It still rises and falls, just always above zero. Look at it on an oscilloscope and you'd see a series of humps. Better than raw AC, absolutely. But your sensitive electronics would still hate it. A microprocessor needs rock-steady voltage. Even a tiny ripple can cause crashes, noise, instability. So engineers add one more weapon, a filter capacitor. Place a capacitor across the output of a rectifier, and something beautiful happens. When voltage rises, the capacitor charges up, storing energy. When voltage dips between pulses, the capacitor discharges, filling in the gap. The output becomes smooth, nearly flat, true DC. The rectifier converts AC to pulsating DC. The capacitor smooths it to steady DC. Together, they form the heart of every power supply ever built. Let's step back and appreciate just how everywhere this technology is. That small white brick you plug your phone into, inside it is a transformer, a bridge rectifier, a filter capacitor, and a voltage regulator. Every time you charge your device, rectification is happening silently, millions of times per second. Electric vehicles, their onboard chargers use high-power rectifiers to convert AC from the grid into the DC that charges the battery pack. Industrial facilities run massive rectifiers to power electroplating, aluminum smelting, and electrochemical processes, some drawing hundreds of thousands of amps of rectified DC. Even in renewable energy, solar panels produce DC. But to feed that back into the grid, it must be inverted to AC first. And when that energy is consumed, rectified back to DC again. The rectifier is not a relic of early electronics. It is the backbone of the modern powered world. If this series is helping you see electricity in a new way, the way engineers see it, hit that like button. It genuinely helps this channel reach more curious minds. Subscribe so you don't miss the upcoming episode. And drop a comment below. What surprised you most about rectifiers today? Have you ever cracked open a phone charger and spotted a bridge rectifier without knowing what it was? Tell me, every device around you are running on converted, rectified, filtered power. Now you know how